Quasi source inverter is a new type of cost-efficient power converter which mainly converts DC source from solar energy to AC source for our usage. When the conventional type of power converter comparing to QZSI, there are extra switching devices and resistors needed for power conversion, which results in extra power losses and construction costs. The resistor is required to be connected to capacitor to discharge the voltage. Hence, QZSI system do not need extra switching device and resistor connected to the capacitors itself, which makes its capacitor becomes more flexible, meaning that we can easily to do control on the capacitor voltage to achieve different outcome. The conventional type of power converter has efficiency around 70% to maximum 95%. To increase the efficiency, the system will be more complicated and more costly. However, it was surprised that the simple design of QZSI is able to achieve efficiency from 95% to 98.06%, which means that the customer will be able to save out 1 or 2 months electrical bill. We know that in the future, we will more relying on the renewable energy as well as electrical vehicle. QZSI can save out a lot of energy costs and provide fast charging as it was more easier to control. I believe most of you having the home appliances with smart inverter. It saves up energy costs. For example, the air conditioner allows temperature in the room to be constant with constant power usage, instead of its power usage become high and low and high again. But do you know the inverter using its conventional one? What if we replace it with QZSI? It can save up more energy costs. In solar power system, we know that inconsistent solar intensity and temperature will cause unstable DC voltage and power produced from solar PV photovoltaic panel. Also knowing that the solar panel gradually become cheaper with the advanced technologies nowadays. However, for solar power system in whole around the world, majority of the project cost comes from the maintenance of the battery storage system, which has limited lifespan. If we did not manage it to charge or discharge properly, it will reduce battery life. That's another main reason why many countries or households did not fully utilizing solar energy. So the new solution I made is to connect the battery storage system to QZSI to replace conventional type of converter. When QZSI is connected with battery, it can buffer and smoothen the fluctuation of PV input voltage and power to the load, meaning that it can store extra PV input power and supply energy to compensate the low PV power generated in high load demand. It is also easily to control and manage battery charging or discharging to preserve its life. With its high efficiency, it can also save up a lot of energy costs from power losses. Therefore, the battery connected to the capacitor 1 at the bottom and capacitor 2 at the top will be further investigated in this project. Here is the MATLAB simulation results for QZSI with battery at capacitor 2 and capacitor 1. It shows that the battery is able to charge and discharge correctly in different input voltage level. However, when comparing QZSI with battery at capacitor 1 and 2 at variable input voltage and power, it is discovered that the output voltage and power can be stabilized in almost constant value when battery is connected at capacitor 1. As you can see here, it is because more battery capacity can be used in the system and it can discharge more battery power. Also, the system successfully converts DC source to AC source in the form of 50 Hz. Based on the simulation, it was found that QZSI with battery at capacitor 1 able to stabilize the output voltage and power. Then the project was further verified in the experiment. So here is the project setup for energy store QZSI with battery at capacitor 1 and its overall setup. So here is the experimental results for battery-based QZSI when battery has no power exchange. During charging and discharging, we can see that from the results, the system has completed DC to AC conversion. Here is the experimental results for QZSI with battery connected at capacitor 1. It has proven that the system is able to stabilize the output voltage and power with variable input voltage. Also, the battery is able to charge and discharge correctly. In the future, we will more relying on renewable energy. Imagine almost every household around the world have installed solar power system with battery-based QZSI. Its high efficiency and reliability allowed them to save up a lot of money. Not only that, the company which is selling this product can also sell the service to help customers for maintenance. They can also sell the license to the other company. Moreover, for high voltage direct current HVDC transmission line, majority cost also comes from power converter for DC to AC conversion. If we replace QZSI with conventional power converter, it can save up a lot of material costs and reduce significant amount of power losses. That's all from me. Thank you.